What's going on, guys? Let's look at this problem right here. Here this question is asking, a state diagram of a sequential circuit is given in figure 8.18. Find the corresponding ASM chart. Minimize the chart complexity by using both vector and scalar decision boxes. The input to the circuit are x1 and x2 and the outputs are c1 and c2. Okay, here you can see we have three states, s0, s1 and s2. So let's put them first. This is S0, and after that we have S1, and then we have S2. Okay, now for S0 we have output that is 0 0. So 0, the first number is Z1 and the second number is Z2. Z1 is equal to 0 and Z2 is also equal to 0. Okay, then S1, Z1 is equal to 0, Z2 is equal to 1. Then S2, Z1 is equal to 1 and Z2 is equal to 0. Okay, now let's look at the first one. What are the things that's going from S0? From S0 we have this 0 0 0 1 going around, and from this one, this is a matrix, like we have to reduce the complexity. Okay, so, and also we have to know, here we have two inputs, x1 and x2. Here we have x1 and x1 x2. This is x1 x2. Okay, x1 x2. Now here let's see, 0 0 0 1 x1 1 0 1 1. Now here they have asked to reduce the complexity. Let's see, let's put the decision box right here. X1, okay, x1 has 0 and 1. Now if you look at this one, when the x1 is 0, it doesn't matter what is x2 is. X2 can be 0 or 1. It will go to S0 anyway. Okay, it's like 0 and don't care. So it doesn't matter what we have for x2. That's why I put x1 alone, because if it's also depend on x2, we had to put the vector box. But here you can see, if the x1 is 0, it will go, it doesn't matter what is x2 is, it will go to S0. So we can just put 0 connected to S0. And if the x1 is 1, it doesn't matter what is actually you know, this is like each number is x1 x0 x1 x2. The first number is x1 x2 x1 x2. So it doesn't matter what is x2 is, it will go to S1 anyway. So we just connect it right here. Okay, now for the other things it doesn't work this way, because here only this one has that much that kind of situation. For the other ones we have to do the vector decision box. You can also do the vector decision box for this one, but here they have mentioned we have to minimize the chart complexity by using vector and scalar decision box. This is minimizing the complexity. You can also use the vector box. Vector box look like this. This one has x1 x2, and it will have 4 choices. Since we have 4 input, like when we have 4 in 2 input, 2 to the power of 2, we have 4 output. It can be 0 0 0 1 1 0 1 1. So we have to put it in the vector box. That is 0 0. Then we have 0 1 0 1 1 0 1 1. Okay, now let's see what happening. What are the things that's going outside from S1? If it's 0 0, it will go back to S1. If it's 0 0, it will go back to S1. And if it's 0 1 1 0 1 1, it goes to S2. So if these three conditions are met, it will go to S2. Okay, now let's see what are the things going outside from S2. From S2, if it's 0 0 1 1, it goes to S1. So again, I put a vector decision box. X1, X2, 0 0 0 1 1 0 1 1. Now from S2, if it's 0 0 1 1, it goes to S1. 0 0 1 1, it goes to S1. Okay, and if it's 0 1 1 0, it goes to S0. 0 1 1 0, it goes to S0. And that's the ASM chart for the given question. And that's how we do that. And also, if you want to draw this one using, like, you can also use this vector decision box for the first one also. But what we did is, here you can see, for x1 x2 we have 1 0 first, and then after that 1 1. So x2 can be 0 or 1, it doesn't matter. It depends on x1. If the x1 is 1, it will go to S1 anyway. That's why if it's 1, we just connect it to S1. It's like 1 and don't care. It doesn't matter what is x2 is. It will just go to the S1. And if you look at this one, in which situation it goes back to S0? x1 x2. x1 can be 0 and x2 can be 0. x1 can be 0 and x2 can be 1. So it doesn't matter what is x2 is. It's like 0 and don't care. It doesn't matter what is x2 is. If x1 is 0, it will go back to S0 anyway. That's why we just put, if it's 0, if the x1 is 0, it will go to S0. Okay, and that's why we can reduce that's how we can reduce the complexity. And that's because that situation only happens for S0. For others, we don't have situation like this. For example, if you look at S1, we have x1 and x2, but it depends on x2 as well, because if x2 is 1, it doesn't go here. For this one, if you look at this one, x1 is 0, x2 is 0, and x1 is 1, x2 is 1. So it's like don't care for, like, it will go anyway. But we don't have situation like it depends on just one thing. If it depends on just one thing alone, then we can use this scalar decision box. Or, like, if you want, you can also use the vector decision box. But if you want to minimize the complexity, we can do the don't care. Like, if it just depends on one thing, we can just use the don't care and reduce the complexity by simply putting one input and reduce the complexity. Otherwise, if you do by this one, like if you put the vector box like this and do this for this one, it's not wrong, but it's not minimizing the complexity. So according to the question, this is the correct way to answer. I hope you guys find this video helpful. Thanks for watching. And if you're trying to learn Digital Logic Design 2 or computer architecture, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.